Okay, Zener diode noise. Okay, I will be doing a demo on the Zener diode basically. Do they generate the noise, and how do you solve the problem? Okay, this is a classical connection of the Zener diode. So basically I got my power supply, benchtop power supply. I will show you. It's a high quality dual benchtop power supply, so the voltage is very stable that I'm going to be feeding over here. And then with the decade box, I'm basically simulating the resistor, and then I've got the Zener diode. So firstly, before I connect anything, I'm going to measure on the scope, and I've already got it connected between the input. In other words, that's actually output of my power supply that I'm going to be applying the voltage to the circuit over here. And if you look at it over here, you will see that there is virtually no ripple, very, 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 very tiny ripple coming out of my benchtop power supply. So it's a very stable voltage. Right now I have adjusted it to just above the knee, which is 15-16 volt or so. And then as I said, now I'm gonna disconnect. Let me show you. So we can see I had no ripple coming out of my power supply. Right now I'm connecting the scope, my negative and positive over there, and here is my power supply. Here is my power supply going via the decade resistor box, and I'm using, a few kilo ohms resistor to limit the current going through the diode. So I'm connecting it up, and now let's look at it. And the circuit is generating the noise. What are we getting over here? Because that's where my scope is right now, across the Zener. And let's look at it. Voila! Yo, it's too much noise. Okay. Now, if I disconnect, look at it here. Let me do it this way. If I disconnect, look at it there. It is nothing. If I connect up, it's plenty of noise. Okay. So the diode is generating the noise, and I'll explain to you why and why we're getting such a strong noise measured across the diode. Okay, now there's two reasons. Okay, a Zener diode is basically a diode that basically operates like any other ordinary diode if it's forward biased, and conducts above 0.7 volt. Yet the Zener diode is primarily used in reverse biased, as you can see in the circuit. That's your cathode, that's your anode. So it's reverse biased. And in this example, I'm using a 15 volt Zener. If I exceed the voltage, my input voltage bigger than 15 volt, okay, over here the diode will be reverse biased, and it will start abruptly at exact Zener voltage, which in this case is 15 volt. It will start conducting, and it will try to make a shot across here, and then in turn it will try to keep the voltage. So the voltage output would be approximately plus minus 15 volt. Now the sharp Zener effect is achieved how? By doping the actual depletion layer within the actual PN junction of the actual diode, making it very, very, very thin. So the movement of charges within the diode, within the depletion layer, is very fast and abrupt. And of course, with such a fast, chaotic, should I say, changes within the Zener diode, all of a sudden, within the depletion layer region, lots of noise and ripple is actually generated. plus, because we got a volt drop, and if there is a volt drop, that means there is flow of electrons, and that movement again is generating plus maybe noise that gets picked up, etc., from the other circuitry and so on. So basically we got the resistor noise plus the actual Zener sort of generated noise, and that can be very detrimental to many circuits where the Zener is used as a voltage regulator. So how do we actually solve the problem? Very simple, okay, very simple. What we do is, let me show you. Okay, this is the Zener diode, that's the sign, that's more or less what they look like, that's the original way of connecting it. And then of course this is my setup. I got the load resistor, I got the Zener. How do you solve the problem? Very simple, by putting a capacitor across the actual Zener diode directly. And from my experience, and when you, without going into lengthy calculation, your starting point would be from about 4.7 microfarad in order to eliminate the noise. So now I've already shown you on the scope direct from my power supply. You can see over here right now it's across the diode without a capacitor, okay, without a capacitor. So right now the noise is too big and too strong. So how do we eliminate it? Very straightforward. Of course we use electrolytic cap, and you just got to watch for polarity. Of course that's my positive and that's my negative. So I just put it across, and then let's see what happens on the scope when I actually put it. Let me just connect it up over here. Okay, right now it's connected. Look at it there. Now I'm gonna disconnect it. Watch it there. Okay, now I'm connecting it. You can see it. It straight away reduces the actual noise generated within the depletion layer of the Zener diode, plus the noise coming from the actual resistor because of the flow of the electrons. So basically the rule of the thumb would be, wherever you use, in whatever circuitry you use Zener diode, is to put a small little electrolytic capacitor, of course with a bigger voltage than the actual input that you're going to be applying. So if it's say 17 volt or wherever, my Zener is say 15 volt or wherever, I should use at least 25 volt capacitor type of thing. So let me do it one more time, and okay, so now I've got it connected again. Let's look at it on the scope. Now it's connected. Now it's disconnected. No capacitor. No capacitor. Now I'm gonna connect it up again, and then let's look at it. Voila, it noise is gone. No cap with a cap. So as I said, it should be a practice for any electronic designer or guy that fiddles with electronics, and that is put the capacitor across your Zener diode, direct across the Zener diode, in order to eliminate the noise and ripple generated by the resistor and by the Zener diode. However, I can't remember which company, I think it's On Semiconductors, if I'm not mistaken, I speak under correction. They have come up with a special kind of a diode that actually the depletion layer is being reduced to an acceptable noise generated within the depletion layer has been sort of reduced to an acceptable level. So it does not interfere on the output wherever other circuitry gets applied, wherever you use the Zener diode to stabilize the voltage. So on that note, we got basically plenty noise, no capacitor, and then capacitor across the diode. There we go. No capacitor, capacitor. All right. Thank you for watching Batos Zener diode noise, and how do you eliminate it? Very simple, with a simple electrolytic cap. Thank you for watching.